Hello students, welcome back to my channel. If you like the video, do hit the like button, share and subscribe, and also hit the bell icon for more videos. In the previous video, I have explained the basic things of triangles, and now I am going to start with the exercise 2.1, and the question number 1 is as follows. In the question number 1, it contains fill in the blanks. They are given two options. We have to choose any one of it. Now, let us start with the first question. All circles are congruent or similar. I have told you what is meant by congruent and similar. Congruent in the sense, if you go back to the previous video, I have told they are having same shape and size. Figures, two geometric figures having same shape and size. Similar in the sense they are having same shape but size may be different. One can be small, another can be big. Now all circles are congruent or similar. The question arises. All circles can't be congruent because the congruent condition is they should have same shape and same size. They can be similar. Okay. All circles can be of same shape but the size will be different. So all circles are what? Similar. They can't be congruent. So we are going to write it here as similar. Now question number 2 is all squares are similar or congruent? See, all squares can't be congruent again because the squares may be to look similar but they may have different size. So all squares are similar. Size may change. Okay, so they are similar. All dash triangles are similar. Isosceles and equilateral. Isosceles in the sense I have explained you that any two sides will be equal. Okay, in the geometric figure any two sides will be equal and both the sides will not be equal to the third side. An equilateral triangle in the sense all the three sides will be equal. Means all the three sides are having equal length. So what it says now? What will be the correct answer in this? All triangles are similar. Which triangles? Isosceles or equilateral? Now isosceles triangle condition is what? Any two sides will be equal. Similar condition says what? They are having same shape. Now if you consider isosceles triangle, any two sides will be same, that means the shape goes on changing, okay, along with the size. Now here in equilateral triangle all the three sides are equal. That means even if they are having same shape, size may change. So all equilateral triangles are similar. So the answer is equilateral triangle. Why I have told you? Because all the three sides are equal. Okay, that means they are having the same shape here. Here any two sides are equal, that means the shape may change. Okay, so all equilateral triangles are similar. Two polygons of the same number of sides are similar if their corresponding angles are dash and their corresponding sides are in dash. So we have to fill the answer here. Okay. Now two polygons of the same number of sides. Now what is a polygon? First of all, polygon is a closed figure, any closed figure which is bounded by lines. For example, you can take even triangle. Okay, triangle, pentagon, hexagon. Okay, now if you take a triangle, okay, normally a triangle, and another triangle here. Now this is a polygon, okay, two polygons of the same number of sides. Now here there are three sides, here there are three sides. Now they are said to be similar. Similar in the sense same shape but different size. Okay, I am not talking about the size here. If their corresponding angles are equal. Now what is corresponding? Now if we take the angle as A and here as P. Okay, I will take it as A, B, C here, P, Q, R. See, I am drawing this figure to explain you what is meant by corresponding angles and corresponding sides, which is very important to know. Now, if you consider this angle, angle A in this figure and angle P in this figure, so these are called corresponding angles, angle A and angle P. And angle B corresponds to angle Q, angle C corresponds to angle R. So these are called corresponding angles. Okay. See, another example I will tell you. If you take this figure and place it on this, see, take and place it on PQR. So this side will be, this angle comes equal to this, and this will be placed on R and this will be placed on Q. B will be placed on Q, C will be placed on R. So this angle is corresponding to this is corresponding to this is corresponding to this. So these are called corresponding angles. Now what about sides? Now this side, when you place this figure on this side will be equal to this side will be equal to this side will be equal to this side. So these are the corresponding sides. Now have you got it? What is corresponding sides and corresponding angles? Now two polygons of the same number of sides are similar if their corresponding angles are equal. First of all, what is the similarity condition here? Corresponding angles should be equal. This angle should be equal to this should be equal to this should be equal to this, and the corresponding sides are in proportion, not equal. Are in proportion in the sense, suppose if you take the proportion of this side by this side, that means if you take AB by PQ, okay, suppose if you are getting this as 1 by 2, okay, this thing, the proportion condition I am going to explain you it in further video. Okay, before that I will explain you once more here. AB by PQ if you do, okay, AB by PQ, this side and this side equal, okay. So suppose if you are getting the value as 1 by 2 and AC by PR same as 1 by 2 and BC by QR same as 1 by 2, that means they are in same proportion, okay. That means when you are taking the proportion, they are giving, you are getting the value as same, okay, that is called as proportion, okay. So two polygons of the same number of sides are similar in the sense same shape but different size if their corresponding angles are equal. Their corresponding angles are equal. Now here we are getting equal, and their corresponding sides are in proportion, okay, that is are in proportion, or you can call it as proportional also, proportional or in proportion, okay. Now another thing in proportion I will tell you, the measurement of sides will be given. That means if suppose this is 1, this is 1, this is 1, means all the three sides having the same measurement, and these are all the three sides are also having the same measurement. Suppose this is 3, this is 3 and this is 3, okay, 3 and 3. So when you calculate the proportion for both the figures, if you are getting the proportion as same, that is 1 by 2 or 1 by 4, anything, okay, if you are getting the proportion of the corresponding sides as same. Okay, that means the corresponding sides are in proportion. Okay, so their two polygons are said to be similar if their corresponding angles are equal and they are having same proportion. Okay, this is clear to you. See, this part in the further video I am going to explain you. Okay, now question number 2 is, give two different examples of pair of similar figures and non-similar figures. The similar figures in the sense what? Having same shape but different size, means to look they are same. Now these two figures to look they are same but size is different. You can see one is big, one is small, another is big, one is small, another is big. So to look they are same in similar figures, to look they are same but the size is different, one is big, one is small. Okay, in case of triangle and squares I have taken the examples. Now what about non-similar figures? Non-similar in the sense what? No, they will be not having same shape also, and already they don't have same size. Okay, in the non-similar figures they are not having the same shape and same size also. Now you can consider the example as right angle triangle along with triangle. Now if you see these shapes, they are to look also different and even the size will be different. Okay, to look they will be completely different, they will not be same. So such figures are non-similar figures. For non-similar figures I have taken the example of right angle triangle where one angle is 90 degrees and a triangle. Similarly, circle and triangle. If you see here, circle and triangle, to look they are different. So no same shape or same size. Okay, such figures are called non-similar figures. Now I have given the example, two examples of similar figures and two examples of non-similar figures. Now another thing which is very important to tell you is that I had told you about the polygon. What is mean by polygon? It is a closed figure bounded by line segments, I said. Okay, you can tell this figure as polygon, triangle as polygon, square as polygon, but can you tell circle as polygon? No. Why? Because circle is a curved shape figure. Even though it is closed, okay, condition of polygon what it says, it is a closed figure. You may think even circle is a closed figure, so it is a polygon. No, circle is not a polygon because it is curved in shape. Whereas the condition for polygon is what? The figure should be bounded by line segments like this: triangle, square, right angle triangle, equilateral triangle. So they should be bounded by straight line segments. Okay, so such figures are called what? Polygons, not the circle. Okay, this is clear to you.